Okay, so this screencast is on chemical reactions and balancing. This covers chapter 3.8 in the the 9th edition, and 3-10, or 3.10, 3.8 and 3.9. 3.10 we'll get to in class. Chemical reactions, there's some basic parts. So when we look at a chemical reaction, for example, one that you should be familiar with, we have 2 moles hydrogen gas, 2 moles oxygen gas, leading to 2 moles of water gas. We can look at this, and there's obviously some energy that comes in here. Maybe you could get a liquid out of that, but we have some very basic parts. On the left-hand side, we have the reactants, and on the right-hand side, we have the product or products. We have our symbols down here that tell us the phase or state of matter. We have our coefficients, which tell us the number of moles in that reaction, and we have the arrow indicating the change. So in a chemical reaction, we want to make sure that we can balance the reaction. Balancing a reaction comes from the conservation of mass. So the law of conservation of mass. For example, you might look at the reaction between methane, CH4, and oxygen, which produces carbon dioxide and water. This kind of reaction is a combustion. We burn methane in oxygen. And if we look at the nano of this, we start out with C with 4 H's, and they kind of arrange themselves this way. I'll draw them bigger if they're closer, so you can see that one kind of goes away from us. And then we've got oxygen. I'll color those in. Maybe make the hydrogens red. Okay, so these are hydrogens, this is carbon, and these are oxygens. And when these two things react, we want to make sure that it's balanced. So if we drew this, we might see the following. You'll notice I'm not drawing these very well to scale, but conservation of mass says that the number of atoms on the left and the number of atoms on the right of a reaction have to be equal. So if we look at this, you'll notice there are 4 hydrogens on the left and only 2 on the right, and that there are only 2 oxygens on the left, but there are 3 on the right. The carbon looks fine. So what we need to do is make sure that we will end up with a balanced reaction. So let's start with carbon. It looks good. Oxygen, or do hydrogen next. Leave your oxygens for last. We have 2 over here, but we have 4 over here, so I need to add 2 more to this side. But I can't just add random hydrogens. I have to add an oxygen to go with it. So now I look at the hydrogens, they're balanced, my carbons are balanced, same numbers on both sides. Now my problem is my oxygens. I have 1, 2, 3, 4, but I only have 2 on this side, so I need to add 2 more. Turns out they come in the form of oxygen gas. And so my balanced chemical equation is CH4 plus 2 moles O2 will give carbon dioxide and 2 moles of water. So we're just following the law of conservation of mass. If you read in your book, you will notice that there are some symbols you need to know about chemical reactions. S stands for solid, L for liquid, G for gas. AQ is aqueous. That means that it is in solution or dissolved in water, which is different than a liquid, which is a pure substance in water. So balancing chemical reactions, we're going to be following the law of conservation of mass. So you need to make sure that you are ensuring that the same numbers of atoms are on both sides. When you are balancing, the first step that you do is you write the reaction without balancing it. So unbalanced reaction, you just get the products and reactants down. So for example, let's look at balancing a chemical equation, example 1, which is on page 107. I'll do this one together with you. We're told that solid ammonium dichromate, which has the formula NH4Cr2O7, so ammonium dichromate, and it's solid, reacts with, when it is heated, it decomposes into solid chromium oxide Cr2O3 solid, nitrogen gas, and water vapor gas. This reaction is unbalanced, but I've written the the reactants and the products. And to get that reaction to happen, like I said, we are actually heating it up, so this is a decomposition reaction. Now, the trick here that you need to remember is that once you have written the reactants and the products, you can't change those formulas. All you can change are the prefixes on those formulas. So when you're getting ready to balance, the only things you can change are where I have red dashes. A lot of students will be tempted to start changing the formula, but remember, when you change the formula, you change what that thing is, and the law of constant composition says that that can't change. All right, so what I suggest in terms of balancing is that you first and foremost keep polyatomic ions together whenever you can. So balance them as a whole. Okay, you'll notice that that is not necessarily possible in this case. I first want to look at the ammonium, and I look, and there's no ammonium on the other side, so I can't leave that one. The dichromate, there's no dichromate on the other side. So I can't do that. That's why I say if possible. And my last word of advice is do oxygen last. It just ends up being easier that way. So let's start with the nitrogens. Let's just start on the left. So in ammonium dichromate, which I wrote wrong, there are 2 nitrogens, and if I look on the right, I've got 2 nitrogens. I'm balanced so far. Hydrogens on the left, I have 8 because there are, 2 times 4, so that's 8. Over on the right, I only have 2 hydrogens, so I'm going to put a 4 there. That makes that 8. So my nitrogens are good, my hydrogens are good, my chromiums are good, they're already at 2, and then oxygen's at 3, but I also have 4 more over here, that makes 7. So I've got 3 oxygens here plus 4 more over there, because that 4 goes all the way over to this, and that makes 7. So I compare on the left, nitrogens I have 2, hydrogens I have 8, chromium I have 2, and oxygen I have 7. On the right, chromium 2, oxygen 3 plus 4, so 7. Hydrogens I have 8, and nitrogens I have 2. So they check, and my equation is balanced. Okay, so that's kind of a trickier one. There are some other exercises that I'm having you do tonight to try it. Take a look at the second example of one where you can sort of look at doing the oxygens last. And balancing, you're just going to have to practice it a lot. It's one of those things where the more you do, the better it is. Problem 100 for tonight is 5 or 6 balancing. You're just balance, balance, balance. I also have some worksheets that I'll hand out to you tomorrow to do some more practice with balancing. It's just one of those things where you start to recognize patterns the more you do it. So we'll just keep doing lots of balancing.